Here's example 2 of the stoichiometric coefficients topic. It says, what is the total number of carbon atoms on the left-hand side of this chemical equation? Here's our yield symbol. To the right of the yield arrow are our products, that is the right-hand side. To the left are our reactants, this is the left-hand side. I know I have two different substances. Here are two reactants. Each reactant is separated by this plus sign. So this is reactant 1. Here is reactant 2. Let's find the total number of carbon atoms in each reactant and then add them together to find the complete number of carbon atoms on the left-hand side. So if I look at this first substance, our first reactant, I see carbon present in many different spots. Here, here, and also here. So let's add up our carbon atoms in this first reactant. So when I look, there is no subscript after this carbon atom, so it's assumed to be 1. This is also not in parentheses. So the total number of carbon atoms I have in this spot is 1. If I go over here where carbon is also present, there is no subscript, so it's again assumed to be 1. But this is within parentheses with a subscript of 7 outside the parentheses. So this 7 applies to that carbon atom. So I have a total of 7 carbon atoms here. In this position, there's no subscript there, so it's assumed to be 1, and this is not in parentheses. So the total number of carbon atoms here is 1. So the last step is to take all of these number of carbon atoms and multiply times the stoichiometric coefficient. Well, guess what? Our stoichiometric coefficient is also 1. So what is 7 plus 1 plus 1 equal to? 7, 8, 9. Well, the total number of carbon atoms, 9, times the stoichiometric coefficient, 1, gives me 9. So there are 9 carbon atoms total in this first reactant. Okay, let's look at this second reactant. Can we find carbon atoms present anywhere? If I scan, I only see oxygen atoms. So in this case, the answer would be 9. Why? There is no carbon present in this reactant. Carbon is only present in this reactant, and we added up all of the carbon atoms multiplied by the stoichiometric coefficient to get a grand total of 9.